Before assembly, the seal must be closely inspected for the following defects. No nicks or tears on the circumference of the sealing lip. If the seal includes a garter spring, check if the spring is placed correctly. The seal outer diameter shouldn't be damaged. Any damage disqualifies a new seal from use. Never reinstall a used seal because there may be defects you can't see, for example cracks or bubbles on the sealing lips. Beyond the seal itself, the bore and housing should also be carefully examined. The edges of the bore must be burr and nick-free. The bore roughness and chamfer must meet ISO 61941 guidelines. The shaft and the chamfer of the shaft should be inspected to ensure there are no nicks or burrs, and it should be finished to ISO 61941 standards. For further information, mind that a new seal should never be run in the same shaft wear track as an old seal. If grooving is present on the shaft surface from previous service, two options are possible. A spacer can be placed, so the sealing lip runs on a different position on the shaft. Or you use a shaft repair kit from Trelleborg Seating Solutions. No change of the seating dimensions is necessary. This is a summary of the most important facts presented in this chapter. Following these instructions should ensure a good preparation for the assembly. Continued lubrication prior to the installation of the seal and the shaft lip minimizes wear and maximizes service life. Do not consider lubricating the outside of the seal because of leakage and pop-out. Install the seal in the correct direction. When replacing a previously used seal, care should be taken to install the new seal with the primary lip facing in the same direction as the old lip. The easiest way to make sure this is correct is by noting the direction the original seal was facing. This will avoid leakage upon startup. To avoid angular misalignment, the seal must also be installed perpendicular to the center line of the bore to help align and seat the seal. Seal misalignment is the most common mistake in the assembly process. It can lead to leakage or contribute to uneven wearing of the sealing lip. Please see the maximum misalignment table for the maximum misalignment value. For further information, please check the Documents section in the app. The use of a proper assembly tool helps to fulfill these requirements. This is a summary of the most important facts presented in this chapter. Following these instructions should ensure correct assembly of the seal. Installation tools, such as the one shown here, are generally made of steel. They are designed to make contact with the seal near the outer diameter, where the seal is most resistant to deformation. Pressing at the more vulnerable seal inner diameter can distort the case and lead to leakage in service. The right tool guides the seal into the correct position, making backward installation safe and preventing damage to the seal, housing, and shaft. Tools are customized to the application, helping to ensure the seal is fitted properly. For installation, the use of a press is recommended. The right amount of force and assembly speed guarantees a proper installation. Depending on the application, the seal may be installed with the shaft already in place, or the shaft may be fitted into the assembly after the seal has been installed into the housing. Either way, it is necessary to protect the sealing lip from splines, keyways, and burrs on the shaft. The usage of an assembly sleeve or special tool can help. Assembly cones must be routinely inspected to make sure they have no burrs or scratches. Often in the field, the seal will be installed by soft-faced mallets and a strike plate. It is recommended to pound in constant intervals of 90 and 180 degrees around the circumference. Afterwards, controlling seal alignment is suggested. Please see Chapter 2 for correct measuring.